Hello, my name is Lee Floria. I am currently in Bloomington, Indiana, and not in France. And I thank the organizers to allow me to record and submit this presentation in my absence. My co-authors listed are also not present. That's Sarah Burgess and Chris Bauer and Brian Devine. The presentation, I think, had a little bit of a different title in the proceedings, but broadly what I want to take the next 20-ish minutes to talk to you about is work that we have been conducting for quite a while in southern Kentucky along the Tennessee border in a county called Wayne County, and this is on the Cumberland Plateau. And so this presentation that you're seeing is a little out of date in terms of the images and detail, but I've updated the numbers and I'll provide the appropriate context to help make sure I'm conveying the right story to you. So with that said, let's give you a sort of a bit of a primer on where we're talking about. So most of the work that you will see, and I'd say almost all of the work that you'll see here, has been conducted out of a place called the Hideout, which is an old 1950s era farmhouse that a group of cavers rent very cheaply in southern Kentucky to stage our expeditions for survey and science out of. And so you can see, I mean, fairly standard beds, no air conditioning, but we do have running water and we do have refrigeration and microwaves, so it makes up for that. We even have a washing machine so we can clean our dirty gear. This is in southeast Kentucky. This is the Cumberland Plateau. It is most of what you'll see are on two creeks, which is Otter Creek, which I have labeled here, and Beaver Creek, which you can see is nearby on the map. These are tributaries of the Cumberland River. They're on the margin of the Cumberland Escarpment, and the amount of cave that you see here in sort of the reddish pink accumulates to about 65 kilometers of surveyed cave over the past 20 years. The past few years have been more difficult and some pulses of pretty intense survey with small groups, and sometimes very little gets done. So one thing that we found certainly in the very thick of COVID is that we could no longer use the Hideout in the way that we were for concerns of disease transmission in enclosed spaces. So most of what we would do is camp in the forest near the caves with permission, and set up some time to be able to go into the caves with a small circle of people that we had a social trust in with respect to their risk to COVID. And so that helped out a lot. That has abated some, but we still do carry forward some of those risk aversion measures to make sure that everybody involved is disclosing who their social circles are. So this is going to be divided into two parts, Sulphur Mountain and Edwards Mountain. We'll take care of Sulphur Mountain first. Broadly, I'm going to give you just a real quick synopsis of where we are at present, because multiple presentations on this cave have been given over the years. This is the Sulphur Mountain system of caves, which includes Bowman's Pit and Scarrett Well. Here are a couple images of Scarrett Well. And that cave collectively has been surveyed to a length of 15.3 kilometers and about 83 meters deep. We have added a couple thousand feet, several hundred meters this spring. We have on our docket for later this summer to add more, so this will exceed 10 miles, which will be a little bit more than 16 kilometers a cave, and that might get close to rounding out what is known in the cave without any further breakthroughs. So that cave has been a big focus for quite a long time for the group. I started surveying there in 2008. We made a connection in 2019 between Scarrett and Bowman's Pit, connecting those two caves and making the Sulphur Mountain system. The way through involves about 15 ropes, quite a bit of rebelay time, and some pretty rough crawls and canyoneering to get from one location to the other, even though they're only let's say 500 meters apart. It takes 4 to 6 hours underground with the ropes currently rigged. So most of this presentation, I want to focus in on Edwards Mountain, which is not very far away, about maybe 10 kilometers away or so. This is much more geologically complex. So on the left is a view out across the Otter Creek Valley. That photo is taken from an outlook, and I don't know if my cursor shows up, but sort of in the north side of this geologic map that you see. The structure contours on this map illustrate the presence of a pretty significant anticlinal structure with a fault in that structure. For a long time, we knew that there would be a cave there. There are several caves there, but for a long time, we knew that there should be a significant cave there because the anticline brings the limestone up to some of the highest elevations in the state of Kentucky, which means that the vertical potential for caves is quite significant in that area. So we're going to focus in on this rectangular area, and in particular, that circle that you see is the location of Spelunker Cave, which is the main focus of the work for the past few years. So surrounding this area, however, from a scientific perspective, has been very interesting to me because of the presence of a number of sulfur seeps that are associated with the shallow petroleum reserve. These seeps are natural. They're not the result of improperly cased wells in most cases. There's a few that are improperly cased wells, but most of these are just natural seeps that are coming out of the shallow reserve. And they're concentrated, of course, on the crest of this anticline because it works as a structural trap. To help us out, we did a significant amount of geologic mapping using traditional mapping techniques to help refine where the contacts are for each of the individual geologic units. We did that on the surface. We did that at cave entrances, such as this pit right off the side of a road that is at the contact between the siliciclastics that you see right at Sarah's head and higher, and the carbonates which occur at her head and lower. And so finding those contacts is very important to help mapping that out. So Spelunker Cave is sort of the creme de la creme of the caves in this region. So we have I don't have the history in front of me, but in the early 2000s, a blowing fissure had been documented in that circle area from that previous image on the crest of the saddle on Edwards Mountain at the contact between the siliciclastics and the carbonates. So kind of bringing those back into focus. It was blowing a significant amount of air, and with some chemical persuasion, that fracture was enlarged enough for people to get in the late 2000s. And early mapping found a significant vertical shaft that you see. That vertical shaft is 175 feet. So not doing a good job here translating that into meters, but 50 something meters. And that is the largest of multiple vertical shafts in this cave. That was the previous image was when dry, but sometimes in the wet season, we get a significant waterfall. So we've had to reroute the route into the cave multiple times to help provide a safe way in. with rebelays and redirects to get across ledges, away from sharp areas, and then away from the waterfall. So some significant work has gone into making that route the safest possible. Let's see, next image. There we go. So in the early exploration of spelungers, this would have been in like 2008 to 2011, the focus was on these upper levels that were really close to the entrance shaft, and they're really quite nice passages, as you can see. Great like cross-section morphologies, very dry, lots of gypsum, quite large passages, and that was like that upper level. But the main route, which had only been very briefly plumbed by 2011, led down a crack off to the side of the entrance shaft waterfall, and that then leads to a whole different section of cave, some of which is upper level, but much of which is sort of in the middle to the lower levels of the system. So this shaft that you see the video playing in the lower left with Sarah on rope leads down about 10 meters through this drain into the next section of cave. As you go down into that, you find your way through a fairly large section of dry passages, again with gypsum, and then it takes you to a decision point. You can go upstream or downstream at the bottom of a next vertical shaft of about 15 meters. The downstream had only been briefly explored in 2000 by 2011, and they turned back because it, quote, smelled too bad. After that, there was a long hiatus because the entrance sequence is challenging, and people had moved in and out of the area, and we didn't have the technical expertise or, quite honestly, the gumption to go in there and reroute the entrance series to get into the cave for several years. And that happened again in like 2018. So if you go upstream, you're basically following a fault exposure for at least 2 kilometers, some in very large passage, some of them in tall, narrow passages, but leading up under the ridge into a side valley. And that's where most of the exploration had taken place. Downstream, there were several trips, but honestly, not as much exploration because, of course, it's more mud and more water, which makes traversing through those passages more complicated. But in reality, that is probably where more like need is to put effort into. Only 1, 2, 3 times had people stayed in a provisio type camp that was set up in the downstream section. Many leads are known. People have not gone back. There's probably a lot more cave in that area. More focus had been put into going upstream, and at present, we have about 9.1 kilometers of survey and about 98 meters in depth. So the last little bit of this presentation, I just want to show you a couple of really like the things that draw me as a scientist, and Sarah is also a scientist to this cave, and I've referenced it in other presentations that are submitted for this Congress. One is that there is significant paleokarst that you can see here in this lower left image in particular, and I can highlight it for you. That paleokarst is Mississippian in age, so Carboniferous paleokarst that has been re-exhumed by Pliopleistocene incision. And so we see a cross-section of a 300 million year old cave. It's pretty cool. That paleokarst has been highly tectonized and embedded with MVT deposits because this area, being an anticline with faulting, is really quite tectonically altered. So you see Sarah's hand on a fault exposure. The slicken sides on that fault exposure indicate left lateral motion, which is really different than what is presented on the geologic map because of the nature of this oblique transpression. We think that occurred sort of in the early Permian at the end of the Appalachian tectonics. In the base of this cave are large sulfur seeps, which are really quite geologically interesting. They are very closely associated with those shallow petroleum reserves, but chemically, they are an indicator of processes that are much more complex than standard carbonate acid speleogenesis. I have another talk in the Congress that you're welcome to go listen to that talks about this in more detail. So to end up, what really draws us to this cave and to this area is just the sheer amount of potential that has not been really pushed, even with 20 years of exploration by our group. So this is a cross-section of spelungers sort of oriented north-south, and you can see the upper levels and the lower levels. Where it shows Lee's lead is actually a known cave entrance labeled as GG, which is Green Garter. And then we have a second one called Elimination Hole, which has been mapped, that are at least 150 feet. So that puts us at about 45 meters above known cave below. And if you add all of these leads together along the trend of this anticline and these faults, you get a vertical relief of more than 500 feet of carbonate that can be karstified. And so that number, 500 feet, which if I can do the math in my head, is approximately 150 meters of vertical. That would be, that if we were able to connect that through, would be the deepest cave in Kentucky, beating Mammoth Cave by somewhere around 100 feet or roughly 30 meters. So there is clearly some potential there. And as I said, one of those leads is Green Garter, which is a nice spring coming out of a carbonate lens and then plunging over the carbonate contact near this fault exposure into a shallow pit where at the bottom of that we've had to modify so that we can actually work in there without getting too wet. In the bottom of that is a fissure that blows massive amounts of air in opposite the direction of the water flow. So needs some work, but that could be a significant addition. And then the other is Elimination Hole, which is one of the leads going into this cave area. And here you see Sarah crawling out. We've surveyed about 100 meters at about 30 meters depth into that cave. And there's, again, a blowing lead down there where we've been using some chemical persuasion to try to extend that further. The last one is this place called Gameldonsk. Sort of unfortunate name from a long story at the hideout. But this is the furthest upstream and would have the most depth potential if we could push past some constrictions that are really tight and flood prone. And so we don't have really any main goal to go back there at present, but if anybody wants to go there and try to help enlarge the way through, that could be the way into sort of these highest level parts of the system. In addition, geologically, this cave is located right along the fault, and you can see the expression of the fault very clearly. That's all I have for you today. Thank you very much for listening for these few minutes of this day. I'm certainly happy to answer any questions you have. Please contact me by email or otherwise, and I'd be happy to get back to you. Thank you very much, and have a great rest of your day.